I'd like to introduce Mr. Joe Brule from the National Security Agency, who's been part of the leadership and facilitation of the OpenC2 working group and has been working with industry partners in many different areas to work this effort. So I'm going to turn it over to Joe.
Hear me? No. Well, that's too bad. Well, okay, any questions?
It sometimes takes a minute to...
I normally have an inordinate fear of podiums, but I just wasn't in the mood to fool with the remote mic right now. My name is Joe Brule. I have actually spoken to this group before about OpenC2. And so in today's presentation, instead of focusing on the language or the background or the motivation or design principles, I'm going to very much more focus on where we currently are and our way forward. The one thing to keep in mind is in the whole OpenC2 effort, it's really very much a subset of what's going on with IACD and then ACD itself. And the idea being is until we take our cyber defense systems and decouple the sensing, the sense-making, the analytics, and decouple all those functional blocks and then define standard interfaces, we're going to fail. For the simple reason that we have to be able to take advantage of the cutting-edge technologies and integrate them then into operational environments as quickly as we can. Now, that is the obligatory agenda slide. And you'll notice that on the first slide, I said, well, we're not going to talk about the background or motivation. And then you'll see that the first thing I'm going to talk about is the background and the motivation. Okay, our motivation was to actually decouple these blocks and try to make a future-proof command and control language. That was really the motivation. Okay, and the idea being that we are going to strive towards standards and then make everything pretty much as plug and play as possible. If you took a look at some of our earlier efforts, in fact, we weren't always called OpenC2. We started off as the Course of Action Working Group, and we were going to do all things involved with courses of action and command and control. And then what happened as time progressed, we realized this is a bigger problem than I thought. And so we kind of drew a box. And we said, okay, we're going to focus on the command first. We're going to take one little piece first, and then once we get that one, we'll move on to the next step. The main piece here is we're trying to make it decoupled, modular, and if you will, future-proof. And I'll use a little example if you don't mind, and it's contrived. But I'd say for the foreseeable future, we're always going to have high-assurance Linux boxes out there, so we'll call those HALs, okay? And it's quite plausible, or very common commands might be something like open a port, open a file, open a directory. So you're going to, open the port, HAL, open the directory, HAL. But what do we do when we get the Internet of Things connected? And what are we going to do if we have to open a valve? Or what if we go into a space station, there's a pod bay? Well, in the future, we're going to have a command that's something like open the pod bay doors, HAL. Okay, and then the response might be, I can't do that, Dave. But the point we're trying to make is the actions are relatively static. What's new is the actuators. What's new are the devices that are actually executing that action against whatever attack or target you're trying to work with. And so what we found out very early is we need to actually decouple the actions from the targets, from the actuators, and then we need to have importable data models because the new technology is in fact the actuators. The new threats are in fact the new targets. But if you take a look, what we're doing, we're detonating, we're opening, we're redirecting, we're dropping, we're denying, those are relatively static. If you take a look at the OpenC design principles, the underlying theme here is we're not going to reinvent the wheel. If there is a pre-existing protocol for security, we're going to reuse it. If there is a pre-existing protocol for the so-called message fabric, which is a little bit nebulous at this point, we're going to integrate into that. We're going to minimize our dependencies on any particular protocol or other technology. What we're trying to do is maximize the separation of concerns. And in doing that, we'll be flexible enough to accommodate these new and future environments and protocols. What's implicit here, but I didn't state it explicitly, actually I did. We got to get to the machine-to-machine interface. We have to get to the machine-to-machine communications. And until we get to that point where we can have an automated decision made to an automated action on a machine-to-machine basis that can happen in cyber-relevant time, we are going to continue to fail. Having said that, I understand there is a transition period. And I understand that there is that period where we have to have the human in the loop to get the confidence in these systems, and the human on the loop to watch these systems evolve. But eventually, we have to get to that machine-to-machine interface. Okay, that was all of the background that I was going to talk about, and I want to talk about what we have recently been doing in the way forward. And from this point forward, I would really encourage a dialogue here because I built a lot of time for discussion in this particular slide deck. And so if you have a question, go ahead and just say it contemporaneously. And if we get a little off topic, that's okay because I have plenty of time to recover. If you take a look at our OpenC2 website, we do have a version 1.0 of the spec out. And the work that the APL done was remarkable, it was outstanding, and unfortunately they worked with our 0.6 spec, but at the time they didn't have something, they couldn't live with a moving target, so they just picked one and went forward. We do have a version 1.0 out there. We also have what we called our IA considerations document, and what we were trying to do with that is we understood that we are only dealing with the frame, but there's a whole set of IA considerations that you need to consider and integrate into your system before you actually release it to the wild. We also worked with the STIX working group quite a bit, and the STIX working group is a subdivision of the Oasis standards body. And what we did is we approached them because they have a wonderful frame with a tremendous amount of information in it, but they happen to have a COA field that's currently unpopulated. So they have a course of action field and a structured course of action field. So we actually worked with the STIX community and said, you know, we'd like to actually see if we can leverage that. That actually paid a lot of dividends for us because what the STIX frame does is it provides the indicators and it provides all of the background information that actually allows entity, a corporation, or whatever to determine how that course of action came up. It also provides a means so we can put in the conditional logic and some of the advanced analytics. What the STIX frame bought us is a lot of additional, they filled a lot of external dependencies that we were trying to address. And so it allowed us to keep our language very modular, very simple, very stripped down, and we were still able to get our mission done. On the network, there's actually a software-defined networking profile defined. And so what this person did, or what this group of people did, and it was actually done by SPAWAR, what SPAWAR did is they studied the OpenFlow software-defined networking specification, and then they actually were able to map which OpenC2 commands go to which set of commands in the SDN profile. And then since then, the University of Maryland actually took some of those they took that SDN profile and they actually partially implemented an OpenC2 implementation on SDN. And so that was a huge step forward for us. And so many thanks to the SPAWAR, if there's anybody from SPAWAR out there, and many thanks to the University of Maryland, if there's anybody from the University of Maryland out there. We also defined a schema. Our schema, we started off with the JSON encoding. The reason being is pretty much everybody is going with JSON now, and that's the way it is. Now, STIX 1.2 was still an XML dinosaur, but STIX 2.0 is actually going to XML, and then most of the professional community is, in fact, going with JSON. We are taking JSON, we're actually going to take it to another level of abstraction. We're going to go to ASN.1. And the purpose of that is it makes it a little bit more future-proof. So that'll allow us to validate a frame or a command, even if it was binary encoded or encoded in JSON or encoded in some standard that doesn't exist today. This slide is a busy one, and I actually took a lot of work to get the font as large as I could because there's a lot going on. We have multiple, I'm not going to call them reference implementations. I'm going to call them at this point, they're just prototypes. What we're doing is we're showing that the OpenC2 language does in fact work. There was a joint effort between the NSA and the Phantom Cyber Corporation, and they were issuing commands to a Palo Alto firewall. There was a University of Maryland actually took a very unique approach to the whole OpenC2 problem, because what they did is they realized what OpenC2 does that's unique is they decoupled the action from the actuator from the target. And so the best way to implement that is actually do multiple dispatch on type, which is a special case of the multi-methods. And they were actually able to show that they could very efficiently, with a low amount of overhead, actually issue these commands. The University of Maryland, their implementation was, I believe they were issuing, did I write it down there? I can't read that font. See, I told you it was too bad. But they were issuing commands to layer 2 switches, layer 3 firewalls. I think they implemented an SDN controller, and I think they actually mimicked a server by using a Linux platform. And so they were able to show that they were using the exact same commands with the exact same targets, and the actuators were able to consume it. And so what that does is it minimizes the amount of state that the actual orchestrator has to maintain, and that's a huge implementation consideration. The Cisco Corporation really rose to the occasion on this because they took a proprietary threat intelligence API, and they were using that to generate events to cause a Cisco ASA to issue denies or allows. And then they even took it a step further, and they're integrating a pub/sub type of environment. And in some of their prototypes, we actually have OpenC2 messages being sent directly to the firewall in the hardware. And so this is actually, there's no glue code, there's no proxy or shim type of code. We actually have a case where it's not available for sale now, but we actually have a case where there's a prototype piece of hardware out there taking native OpenC2 commands. And then you heard earlier from Wendy Peters about the IACD course of action implementation. Many thanks to the JHU APL. It was an outstanding implementation. Theirs was actually the most advanced because most of the other prototype implementations were on the order of 5 to 7 commands. They took, it was over a dozen OpenC2 commands, and then they had I think 10 or 15 different actuators they're communicating with. And so that was a remarkable amount of work that the APL did in the context of this effort. So what did the prototypes do for us? Oh, wait, my bad. I got a little ahead of myself. The prototype implementations helped us define some of the gaps and some of the issues we were running into. And so we did understand that the JSON schema did need a little bit more work, and we do need to move that towards ASN.1 coding. We did identify some issues with the actions in some of the OpenC2 commands. One that came out from every prototype implementer is your response action is ill-defined and is actually ambiguous. And so we understand that we have to work that. We also have to work on the alert action. We also need to really kind of nail down a baseline implementation, because to say, well, security is just an overlay, don't worry about it, that's an external dependency, that's kind of a nasty thing to do. And we really should have a baseline implementation where we're using HTTPS or we're using one of the pub/sub environments. And we really need to get that nailed down so people can actually have a baseline to work with. We also need to get some of the implementation considerations identified and recommendations made for them. We need to know something about propagation delay issues. We need to know about, well, what happens if there's a packet loss, drop packets, drop commands, drop frames. How do you maintain the state of the actual network? If a new device comes up and it's a whole new configuration, how do we deal with a command that's not quite understood, and what should those acknowledgments be? And those are some issues that we definitely need to work. Having said that, we do have a 1.0 version of the document out there, and most of the feedback I'm getting on it is it's actually pretty good. We're also working to get a little bit more public in our presence, and at the risk of upsetting everybody in my home agency, that's not as trivial as it sounds. because what we tried to do is we tried to get a charter out, and we actually wrote that charter in November, and it's still not out. Or no, it came out Friday. It actually came out Friday. So the OpenC2 forum has been in existence for 14 months. We wrote a charter 11 months ago, and we're barely getting it out. So that's just an illustration that getting that conspicuous web or that conspicuous public presence is not as trivial as it sounds. Having said that, we got it through. It's ready for signature. We're opening up the website. We have more of these things posted. All of the code that we, to the greatest extent practical, we're putting Apache open source licenses on all the code, and that is in fact on the open side of the website. So we're trying to get that more open and more conspicuous web presence out there. So the next steps. The prototype implementation work done by our partners was outstanding. And by the way, I do want to stomp something. The NSA was a partner in 2 of the the prototype implementations I talked about earlier. The other 4 we had nothing to do with. This was actually our industry partners rising to the occasion, and they were actually doing the prototype implementations, and they did it essentially on their own. And then they fed back the results to the group. That was a huge success from our point of view, because what that means is this really is a vendor buy-in. In the 1970s, if the DoD said jump, the entire computing industry would say how high. Right now, all of US government is less than 5% of the IT market, so we're just not going to drive it like we used to. If we don't get the industry leadership to say, this is ours, this is what we want, we built it, then we're not going to succeed. It's that simple. We need to take these prototype implementations and actually make them into full-blown reference implementations. And by a full-blown reference implementation, what I mean is the ABC bearing company can take this baseline as a starting point and use it to protect their environment and tweak it in accordance with their unique needs. The prototype implementations we have at this point demonstrate that OpenC2 works. What we really need to do is get it to that baseline reference implementation so somebody could actually use this to defend their networks. We need to gather more and more use cases, because what we were doing is saying, gee, wouldn't it be really cool to do this? This is where I'm reaching out to the IACD, this community of interest, is let's get more and more of those use cases. Let's make sure that this language is in fact robust enough to cover the span of the use cases. And so at this point, this is a plea to this audience and to your friends and even people that aren't your friends. Let's get these use cases documented, let's get them identified, and let's work towards fulfilling those use cases. Actuator profiles. If industry doesn't build a device that understands OpenC2, then we created a whole bunch of documents that nobody cares about. And so what we really need to do is get that profile out there for a particular actuator. And that way we can communicate that if you're a router and you're claiming to be OpenC2 compliant, this is the minimum set of actions you got to support. These are some of the modifiers that you should be able to support. Here's some optional specifiers that you need to support. If we don't get that out there, what we'll run into is a whole bunch of companies claiming to be OpenC2 compliant because they support one command. And so I don't want to go down that rabbit hole, and I'm not going to identify by name any other standards efforts, but some of the standards efforts did not define those vendor profiles to allow them to delineate exactly what they mean by OpenC or by being compliant. And that led to a lot of interoperability and just failure to implement type of issues. Our end goal, I'm speaking as a government person, my end goal is I want to be able to point to an RFC, a standard, or something and say, vendor community, we're trying to protect a submarine base. You have to use these protocols. You have to be in compliance with these standards. That's my end goal. In order to realize that, we really do need to have a well-defined standard that people can actually build to. In terms of standardization, the question always becomes which one? And there's a lot of them out there. There's the IETF, there's ISO, there's Oasis. We picked Oasis for the simple reason that we had a pre-existing relationship with them. And we actually worked quite well with them, and we had the Styx COA working group going on. And so it became a natural step forward to approach Oasis. In our preliminary discussions with Oasis and taking a look at the work we need to do, we believe that in the February to March 17 timeframe, we're going to be able to give Oasis pretty much a complete package. And at that point, they will stand up a technical committee for OpenC2. I do want to highlight something. This technical committee will actually be separate from Styx and from Taxi and from the rest of those. The reason being is there was certainly a lot of overlap, but we're still independent of each other. And so what I always tell people is, Styx doesn't need us and we don't need Taxi, but we do work nicely together. The bottom bullet, I hope I can stimulate a discussion here. What happened is, actually I'll give you a little history because some of it's kind of amusing. One day, my boss walked up to me and said, "You are the lead for command and control for ACD." And I thought, wow, that's a really cool title. And then about 5 minutes later, I realized I have no idea what to do, okay? I had no idea what to do. So anybody that was foolish enough to return one of my emails or one of my phone calls got invited to a kickoff meeting, and that's essentially how this thing started, is I had a bad problem. I did not know how to solve it. Fortunately, a lot of industry was wrestling with this as well, so they showed up to the meeting. And then what we did is we said, well, let's go ahead and formalize this because we had about a dozen companies, and that, by the way, grew to about 25 or 6 companies, and we had maybe 15 or 20 people. That number grew to over 100, and I thought, we really need to standardize this, or I'm sorry, to formalize this. So we thought, well, who ought to be the chair on this? And people said, well, why don't we ask Neil Ziering? We'll have Neil Ziering be the chair of this. And everybody thought that was a great idea. And so we wrote up a charter, we put Neil Ziering's name on the charter, and we did all this work. And then we showed Neil the charter, and he looked at it and he said, well, did anybody ask me to be chair of this group? And I said, that was on my to-do list. Okay, that was a very awkward moment. I gave you all of that useless background information because the very condensed version of the story is the government did not want to lead this group necessarily. We would have rather been a partner in an industry-led group. And so what we were hoping is that somebody or some entity or some other group would stand up like a not-for-profit like what do they call them, 507Cs or something? 509, I have no idea. We were hoping that this would actually become a true industry-driven group. Based on the conversations we've had with the partners in the OpenC2 forum, it looks like they're actually comfortable with the NSA leading that group, which I found amusing because everybody else hates the NSA, but apparently our industry partners get along with us okay. I think we have a pretty good handle on the frame. I think by the late February, early March 2017 timeframe, we are going to be in a good position to go to Oasis, and I think we're going to have that 85 to 95% solution, and we're hoping it'll be a matter of tweaking it. We actually have, by the way, there's a lot of you out there. For all the people that participated in this forum, I can't thank you enough because the work they did was phenomenal. They actually, we started with essentially nothing, and 14 months later, we got to a working spec, and we actually got to prototype implementations. We're at that point now. So the question becomes, what is the next really hard problem we ought to address? What is the next issue? Is it some aspect of the message fabric? Is it some aspect of, well, how do we handle the decision logic? Because between the lines, if you look at this, we're very much focused on the acting block within ACD, but there's also the sense-making block. You got the sensing block, and you have the decision-making block. Which blocks should we focus on? What is the next piece of the protocol that we ought to address? I threw this on here because I did want to show that in a 14-month period, we made a remarkable amount of progress. And I would like you to believe that it was due to the brilliance of the executive director. Okay, nobody's buying that. Simply stated, we took on a problem that a lot of people were already thinking about. Industry was already working towards that standardized command and control language, and I'm not going to name any companies by name, but I even asked one of the orchestration companies, you know, what was your motivation for doing so much work that you did for us? And they said, our secret sauce is inside that orchestrator. We don't want to spend an inordinate amount of resources trying to do the actual commands we don't want 50 different versions of the word block going to 50 different actuators. We want to be able to write a single command, block. So they said it was actually within our interest to do this. The orchestration industry has exploded. I mean, 3 or 4 years ago, there was, what, 2 of them? And now there's dozens upon dozens. If you went to RSA last year, I lost count of how many new orchestration companies are out there. The router industries like Cisco's and the Junipers and some of these, they are very much trying to open up, and they're very much trying to open up their APIs and open up their SDN implementations. And the take-home message is the time was perfect to make this happen, because I think the entire community recognizes that our cyber defense will be much more effective if we have the integrated whole of parts as opposed to a whole bunch of individual products acting as ships in the night.